everybody. Welcome to CS109, our second lecture. This time I'm going to talk about scraping and how to get all the data you might want to get your hands on. But before we start with that, a few announcements. First of all, we have over 400 signups on GitHub, so thank you, good work. Everybody filled out the survey. If you haven't done so already, please be sure to really do it this evening, like now. So all you need to do, it's not about solving, well, there's nothing to solve. It's not about doing all of homework 0, right? It's really just signing up for GitHub, get your GitHub account, and fill out the survey and give us your GitHub username so we can register you for the homework submission system. If you don't do that, you won't be able to submit homework 0, which is required. You also will not have access to homework 1, which is coming out on Thursday. So really, really, really do this now. Also make sure you are on Piazza. Like if you don't have a Harvard email address, you cannot sign up yourself. What you do then is you write an email to staff@cs109.org, and we're going to sign you up. But if you have a Harvard email address, just go to Piazza. It's linked on our homepage, right? Like at the menu up at the top. There's a link to Piazza. Just go there and sign up. Because all the announcements are on Piazza. Like this lecture has been online this morning. How many of you have the lecture notebook already now on your laptop? That's way fewer than I thought. How many of you are not on Piazza? So let's do the sanity check. How many of you are on Piazza? OK, great. So I made the announcement this morning that the slides are there. So maybe you didn't check every 10 minutes whether there are new announcements. You can clone them now from GitHub. I'm going to show you the link. But if you're not on Piazza, go there. Things like this that are really useful, sometimes time sensitive, are going to be announced on Piazza. Then about all the Git stuff, we actually have even more help for you. Rahul, our head TF, has been really, really great and hardworking and made a few more instructional videos for you. So in addition to the section video and the office hours you can go to, you also now have this additional resource. So if you click on that link in the slides you're going to get in a minute, it's going to bring you to our YouTube channel. And you can get even more Git help there and instructions. So as I said, homework 0 is due on Thursday. And you can only submit it if you're signed up for our Git system. And homework 1 is coming out on Thursday, and you also only will have access if you're subscribed. So as so few of you actually have the slides, let me point out to you how to get them. Now let's do it the right way. So our homepage, right? cs109.org. As I said, up here is the Piazza sign-up button and how you can reach the forum. And here's the link to our GitHub repository. So this is not the repository where the homeworks will appear. Right? This is why it's so important for you to sign up. This is where all the public resources are. The lectures are public. So all you need to do now is clone this repository. So you just go to the homepage, click on the GitHub link. It's going to get you to the GitHub homepage. And here you can get the URL to clone this repository. I don't see many people typing. This lecture is going to be really, really code heavy. And if you clone this now, you can actually work along. And I'm going to have some quizzes. And I would really like you to be able to do this. So it's best if you just download this now, please. So what you do is you open your shell, whatever, right? And you do git clone. And you paste that link here. You can actually just click the button, and it's going to copy it to your clipboard. And all you need to do is paste that link after this and hit enter. If you don't want to do that, you can also, if you don't want to do that at all, you can directly click on that file, And it's going to show you a rendering of that notebook. This is not executable, but you can at least read along maybe better with the lecture. So who would like to clone the notebook but still needs 1 or 2 more minutes to do so? Okay. Okay, I'm just going to talk more in general about the lecture today. So what I want to do is, this lecture is going to be really, really heavy on coding. Because the idea is a lot of you don't know Python yet that well. Even fewer have worked with Pandas. And most probably even fewer have done any scraping. So, and all 3 of these require you to actually know your tools. It's not just about learning the concepts here. It's about learning how to use Python to achieve what you want. So we're going to do a lot of coding this lecture. I'm going to show you an introduction to Pandas, how to read a table. We're going to do some plots in Pandas, which is actually very nice and sometimes easier than with matplotlib. And then we're going to talk about data scraping. What is data scraping? Anybody ever heard about it? Yes? Yes. Yes, it's all about getting information from the web in a format that you can use it and analyze it and do whatever you wanted to do with it. So there are 2 different ways to scrape. Well, 2 main roads, I think. One is to directly go to website and scrape HTML code and scrape the content of web pages. And that means you can basically get the information from any website you can open in your browser. You can. That doesn't mean you should. You can also get data with an API. So that's way more comfortable. A lot of web pages just acknowledge that a lot of people want to use their data, so they provide an interface for you and make it easy for you to get to that data. We're going to talk about both. I'm going to start with the web scraping, because the APIs are really specific to the application. Like a Twitter API is different from Rotten Tomatoes. Those are the 2 examples I have in this lecture, which is again different from what Google might provide you with. So with APIs, it's really about reading the documentation about that API. Whereas web scraping, like from a website, it's basically the same process over and over and over again, not so much depending on what the website looks like. How's the cloning coming along? OK, cool. So we are using IPython notebooks in the course. You all have in homework 0 all the instructions how to get your own IPython notebooks up and running on your laptop. In this lecture, I'm actually even using IPython notebooks as my slides. And I'm just realizing now I'm not in full screen. So these slides are IPython notebooks, which also means the notebook you just cloned are these slides. So it's not 2 different versions. So just basic Python, you have these cells, right? You can have markdown cells where you type comments and things, explaining your code, explaining results, discussing plots you made, things like that. And you have these code cells in an IPython notebook. And you here see I just did hello CS109, I love Python. And when you execute that, you execute by either Control-Enter or Shift-Enter. And it says, hello CS109, I love Python. So there's the output now that the code produced. Very basic. Important things to know. IPython notebooks are also really, really nice to the programmer. Because, for example, what you can do is this A here is now a NumPy array. And that is a class. And maybe I don't know much about it. But IPython notebooks have something really useful, which is tab completion. So what I can do now is I do a dot, and I hit tab, and you can see I get a context menu with all the different functions I can call on A. And because A is this NumPy array, I have things like argmax, argmin. So often, if you use a function, Python already provides it. And if you think something is sounding useful to what you actually want to achieve, but you're not entirely sure, there's also inbuilt help. So I can choose this a.clip, right? And maybe I'm not entirely sure what it does. So all you do is you don't do the opening and closing brackets. Instead, you put a question mark, you execute the whole thing, and you get a help docstring. So this is now telling me what the function does. And I haven't even opened Google and asked for anything, right? This is all just provided within the IPython notebook, which is really useful. So this is the quick way to get help. And tab completion also works for long variable names. So don't be shy to use them. It's my biggest advice. Make your variable names speaking. It will help you so much. Like what I just did there, a dot, don't do that. Have example array. I cannot always keep to this convention with the slides because the text blocks get too long to make it visible in the slide format. When you program in your process notebooks for your final projects, do yourself a favor and code in a clean manner. And this taps into my general advice for programming. One thing is, don't be shy to Google nearly any and everything. And Stack Overflow is such a nice website, and they have this policy that there are really no dumb questions. So you can see people coming from Java, from C++, trying to learn Python, just the way you are. And they ask questions like, how do I get the length of a list in Python? And of course, this is stated in every Python book, most probably in the first chapter, but it's also on Stack Overflow. So you can literally just Google these very, very basic things. You're going to have your answer within seconds. So 2 years ago, I actually really liked that sentence in the homework assignments. It said, a programmer is someone who can turn Stack Overflow snippets into running code. It's OK to go there. It's also OK for the homework to get help from Stack Overflow. You just need to acknowledge where you got the help from. But really, don't be shy to Google these things. There's a lot more out there than you most probably think. And don't forget about the tab completion in the IPython notebook. It's really useful, and the long variable names. OK, enough about the general stuff. Let's do pandas. So the first thing we're going to do is just load a table of data. That's the first step you often do as a data scientist, right? Either you have a question and you need to get the data, or somebody comes to you and says, here's my data, what can you do with it? And then the first thing you want to do is load it into Pandas. And the example here is from the movie lens data set. So let me see. I need to remember to execute the cells. So can you go along? How many people can follow along and execute the cells? Can I just get a sign? OK, that is more than half. That's great. So what we're doing here is we're just loading a file. And it's not even a file on my hard drive. You can see I put a URL there that is directly from Group Lens, who gathered the data. So that data is just free, available on the internet. And you can directly put the link and use this read CSV function from Pandas. Pandas has a lot of more functions where you can read from files. I believe it has a function to read from Excel sheets. The CSV files are there. I'm not sure what all it has, but there are a couple of read functions that you can use to create Pandas data frames from various sources. So I just put the link directly there from the web. And I specified the separator. So it's this bar. And then the names are the U columns. And you can see there's this list very up in the cell where I specify the names. because this movie lens data actually is just really the values separated. So the headings are not provided. Those are given in the description of the data. So what I do here is I have a list. This is called a list in Python, square brackets. And I just have as strings the different names for the different columns in this data set. So I know before from the description on the website of this data that this data has a user ID, the age, sex, occupation, and the zip code of a lot of people who rated movies. So I load that data, and PD always stands for Pandas. I import, when you look at the import statements in your notebook, I try to import libraries always with abbreviations so that you know that I'm using a function of a specific library. So PD will always stand for Pandas in my slides. So, and a lot of people use this convention also out there on the internet when you look for help. So PD read CSV, we're reading in the data, and we're putting in this list of names for the columns. You can see I get a very, very nice data frame out here that is already in a cool format. So this is this users here now, is the data frame we created. It's just a table, really. And this has this function now called head. When you call that without saying anything, it's just going to give you the first 5 entries. But it's not only plotting the data, it's also giving you the names of the columns and the index of the different rows. So this is your basic Pandas data frame, where you have all your data together in one neat place. So now we do the same, just with the ratings, right? Same thing, just reading in the file, putting in the names. You can see this is a second data set now that has the user ID, the movie ID, and the rating. This already might be not so nice. We might want to change that in the future, right? Because what we have is we have 2 different data sets here. Both have the user ID. This one describes the user, right? And this one describes what the user rated each movie like. And then, of course, we need a third one that actually has the information about the movies. And you can see the IDs here are the links, right? I have the user ID. I know which user ID rated which movie ID with what rating. And then I have the mapping of the movie IDs and what they were rated like. So it's 3 different data sets. Let me make sure that I execute all of that. So now I want to get some information about the data. So movies was one of our 3 data sets, right? And one of the things I can look up are the data types. So it's just .data type. It's an attribute of this data frame. So I can print that, and here you can see now for each column what is the type of that column. You can see movie ID is an integer type. Then I have 3 unspecified object types and 1 float type. And then we have this describe function here. So this is just because movies is now a data frame, and Pandas gives this nice function for movies, for data frames, which is called describe. And you can see this gives you a summary statistics about your data, like the count, how many are there, the mean, the standard deviation, the minimum value, all these things. So, but the movie data set actually had more than 2 columns. Right? You can see here it had the movie ID, the title, the release date. Why am I only getting a summary for the movie ID and the video release date here? Yes? Yes, because it's the only 2 columns that are number-based, right? It's integer and float. Object is basically too general. Doesn't know what to do with it, with the describe function. You can already see for the video release date, it's not that useful even. So this is how you get basic information out of a data frame. You can also select data, like you can get subframes or just 1 column out of the data frame. And something that is basically just 1 column is called a series in Pandas. So users.head, as I said, gives us the first 5 entries. And if I do users occupation head, I only get this column. It's actually not printing this, is it? Let's do this. Oops. So users.head, as before, would give me the whole table, but now I did users and only occupation.head. And you can see this only gives me the occupation column now. So this is one way to select a column in a Pandas data frame. You just do square brackets, and you give it the name of the column. Remember, that is what we put in before, right? We named all the different columns when we created the data frame. Now we can use these names to address the data, which is really convenient. You don't need to learn indices or try to get according to the sorting. You can directly use the name. Very nice. So now I'm specifying here a whole list. Columns you want, occupation and sex. And then you can take users at columns you want dot head. Let's print that. And I get the occupation and the sex now. So you can also create a subframe, right, from the whole big data frame, a subframe by just passing a whole list of all the columns you actually want to have. So you filter out the data that is relevant to you. And then with ilog, you can actually access rows in your data frame as well. So some more filtering, and the first quiz is coming up soon. So what I do here is I just want to see the old users. And I'm going to define an old user as someone over 25. So what I'm saying is users.age, age is one of the columns in my data frame, larger than 25. And what this part, any guesses what this part actually gives me? Like if I only put this, users.age greater than 25. Any guesses? What is the output of this? Boolean, yes. It's just going to be a big Boolean list. It says false, true, false, false, true, true. So you can pass such a list into the data frame, and it's going to select only those for which this is true. So now I get only the users whose age is greater than 25 here. If I execute this now, in the age column here, it's all greater than 25. So here's your first quiz. Try to filter all users out of this data that are aged 40 and male, and try to get the mean age of all female programmers. And I just saw a nice distribution of hands up, so please team up for this. If you don't have the IPython notebook up and running right now, but your neighbor has, please, by all means, neighbors, don't be shy, talk to each other, and try to solve this. And when you have the answer, give me a brief hand sign. So who has the users aged 40 and male by now? Okay, a bit more time. I'm going to give you one more minute. Okay, time's up. So there are different ways to do this, of course. This was my solution. So I took the users aged 40, right? And then I did the AND. Because this, we said, is a list of Booleans, right? So this is a list of Booleans whether the user's age is 40. This is a list of Booleans showing whether or not it's male. So I do a logical AND of the two, and I get all the users aged 40 and male. That is one way. Another way would be, for example, you could filter first for all users aged 40, save that, and then filter again within that data frame for all users that are male. Right? Both valid things to do. I like to do the quizzes during the lecture, but I'm going to give you the solutions tonight or tomorrow. So I want to keep, maybe I should wait a bit for the DC students so that they have a chance to do the fun too. But you don't need to frantically type in the solutions. I'm going to give them to you. And this is the other part. Users who are female and programmers is what you have to get first. So same as before, I do the user sex should be female, and do a logical AND. The user's occupation should be programmer. So this gives me all my selected users. And then I just use the describe function we had before, right? Like a couple of slides back, I used this describe. And one point of the whole summary was the mean. We said we want the mean age. So it's here, 32.166. So that's one way to get the mean age. Alternatives are you can directly call the mean function. So if you use this tab completion help, you can see that selected users.age dot, and you can see in the menu that you get that there is a mean function. And I sneaked something in here. I only showed you before that you can address a column in a data frame with this, right? Square brackets and the name of the column. You actually can also do this. This is for convenience. So you can do dot, and this is really just the name of that column. And it's also going to give you the column of that data frame. So there are different ways in Pandas to do the same thing. So now comes something more advanced, maybe more for the people who already know a bit about Python and Pandas. I still want to introduce this briefly to everybody, because this is going to come over and over and over in the lecture. So we're going to have it now, the split, apply, combine. I believe Rahul is going to teach the lecture on SQL soon. It's going to be part of that too. And we talk about MapReduce. Similar concepts are coming up over and over again. So there's something very, very useful, which is called split, apply, combine. And the idea is that you split the data into groups based on some criterion. That sounds very abstract. Let's do a picture. So what we have is there's a list here. And you can see I have letters there, A, B, C, and then I have values. And I have 2 A's and 2 B's and 2 C's, and I have different values for all of them. So what I do now is I split the data according to the first column, so according to that key. So what I do get is I get all the A's together, all the B's together, all the C's together, and the values they come with. And now comes the apply part. I can apply a function now to the data that is split in that way. For example, I can ask what is the mean value of the A's, the B's, the C's, right? So I split the data according to the first key. I apply this function mean, and then I combine the whole thing back into one data frame now that has just the key and the mean value, right? So this split step is really useful in a lot of cases because you have the key in the beginning, it's just going to split according to the key. And then you can apply whatever function you want. It's not restricted to the mean. And this is sometimes a concept when you maybe even a bit new to programming, it's hard to think in these terms. But I promise you, the more you practice this, the more it's going to become easy. This is really some way of thinking that you just need to do over and over and over again. And then one day you just look at it and go like, yeah, I just need to split by this key. It's going to happen. So for example, let's find diligent users in our data set. So what we want to do is we want to find the users who rated a lot of movies. So we do have this file, right, that has the user ID and the movie ID and the rating. So what we want to do is we want to split according to the user ID. Right? And then for each user, I can count how many ratings they gave. And then I can combine the results. So here's the result. And this split, apply, combine in Pandas. So the concept is more general. You're going to see this in different contexts as well. Within Pandas, it's called group by. This is the split part. So you see here I have this ratings data set. That was the one where we had the user ID, the movie ID, and the rating. And now what I do is I call this group by according to user ID on this data set. So on the ratings, I call group by according to user ID, right? This is what I want. I want to have all the user IDs listed so that I can count how many ratings each user submitted. And if you do it this way, you actually see I'm getting the counts for all 3 different columns here. So I split the data, and now I apply, right? Split, apply, combine. I split using group by. I apply the count function. So now I count how many ratings there are per user. And then I combine. And that is already done just by assigning it to a new variable. So if I now look into this ratings per user thing, I have the user ID here. And now this is actually a bit odd. I get 3 columns, each of which have the count. Why did that happen? Because I split the whole data frame according to user ID, right? So I didn't just get the movie ID or the rating, but I got the whole data frame split. And when you applied the count function, it doesn't only count the rows, it counts how many user IDs and everything was there. So this is the other version here. If you really just want to do 1 column, then you do this. So what's different here? Here I called group by on the whole data frame. What I'm doing here is I'm pre-selecting only the movie IDs and then saying group by according to the user IDs. That is worth sitting over at home for 5 minutes, like after the lecture. Like I'm using a different column in this data frame, right? And grouped by another column in this data frame. And that works. And then when I call the count function on this, I now only got the actual counts here. Because it's only counting how many movie IDs there are per user ID. Do you have questions for this? Yes?
I was wondering, would it be possible to use like ratings.userid dot another function? Would you use the same dot?
Ratings.user, yes, you should be able to. Yeah, to address columns, you mean? Yes, yes. You can try it in your notebook to check, but I'm pretty confident that yes, you can. Okay, then, oh, sorry, one more question.
When you grab that column and then you work on it, you label it one way.
Sorry, I grabbed the column and I labeled it one way.
So when you grab the movie ID column,
yes,
and then you did the grouping, that movie ID header.
Oh, yes. When I grabbed the movie ID column, the header actually disappeared. That is true. The output here was ugly, is what your colleague points out, right? So I have the user ID here. It's actually still here. It says here the name is the movie ID. It's a different output format. I believe it's because this is a series now. There's only one. It's not a data frame anymore. It's a series that doesn't have these nice borders in the printout. But you can see the name of the value then down here. So there's the movie ID. So let me actually see. Yeah, let's do that. Especially the first part, so the advanced part of this. So the first part of the quiz is get the average rating per movie. So we had before the example, just take this example and modify it. Before we had the number, right, of ratings per user ID. Now I want you to get the average rating per movie. So instead of the movie ID, instead of the user ID, you need to look for the movie ID. And instead of counting, you need to take the average, and this function is nearly everywhere called mean. So, and if you think that is boring, then do the second part. Give me the movie titles with the highest average rating. And I'm going to give you, let's do 4 minutes, then it's 20 past. Just try. Oh, question. Sorry, you need to speak up a bit. The highest average rating, yes, for the second part. For the second part, the highest average rating, it's actually going to be more than one movie. Oh, yeah, second question. Yeah? Yeah.
Still turns the user ID combined with
Oh, so the question is what the output is of this group by
yeah.
thing. So what exactly, what is the output you would like to see? Just like in the split apply combine figure where I plotted them sorted by ID?
So is it like the split part, or because it still prints the table where those are?
Yeah, I'm actually not sure how to print the group by results.
I just print group data.
Yeah.
This gives you the same table.
Yes, because it doesn't actually print the group by, does it? Did it? I don't think it did. Let's try. The question was, so one of the colleagues had a very interesting question, which is, can I access the group by part, the group by data? Let me see. This is cool about this IPython notebook. I can actually try this where everybody else is solving the group data, basically. Let's just get rid of this part. Print grouped data. So that is a group by object that doesn't print anything. But actually very helpful is it's listing here all the functions that you could call. Let's see where there's one that actually looks like it's going to give me the output that the colleague was looking for. Unique. I'm actually not sure. Do we have a Pandas expert here who knows if I can print the group by data itself? I've never tried that before. Yes? Did you find it?
So in the input cell 4, it's not 41.
Yeah.
41. I typed print grouped under slash whatever it is.
Yeah.
Head, and it printed the head.
But that wasn't the group data, was it? User ID, movie. Yeah, but that is not group. That is just the. Where is it? Group data.head.
Because group data here is ratings.groupby.
Let me try. So this is what he did. So I'm not even sure what to make of this result. So I'm going to put the question onto my to-do list and get back to you on Piazza. And anybody else, oh, do you have a solution? Sorry? Anybody else who wants to know whether you can access the group by data directly, I'm going to follow up on Piazza. Yes, different question?
Yeah, I wanted to know if you can print the group data.
Yes, that was the question. Okay, so I'm going to follow up on that one. So I actually went a bit over time now with the quiz. So how is everybody doing with the average rating per movie? Right? That wasn't too hard, I think, especially because we had the example right before. So this is the way I did it. So I now did the ratings and group by the movie ID. And then, as I said, there's this function called mean. So this is really all you need to do to get the average ratings per movie. You can see now I get the movie ID and you get the average rating here. And it's pretty high, which is nice. So lots of good movies in there. And then the second part, did anybody do the advanced part? Yes, there are people. Which movies did you get? You need to shout. Do you hear a movie? Well, now you can read it, right? Do you have the same movies? No answer. So these are the movies I found, the best movie titles. The best is then actually a bit questionable. So what I did was I took the maximum rating. That was indeed actually a 5. I did print that. And then we look, the good movie IDs are now the average ratings, where the average rating is equal to the maximum rating, right? So I'm filtering all the movies where the average rating was 5, and I'm saving the IDs of these movies that I get with the index. So now that I have the movie IDs that got high ratings, I can actually go to the movies data set and look up which of the movie IDs actually are on my list that I got there. So this is a bit more advanced Python that you need here. And this is the list. And I was like, that's odd. I actually don't know these movies, most of them. So what's up with that? And as a good data scientist, we immediately have a suspicion. A rating of 5 is really, really high, right? So what's most probably happening? Sorry, what? Only 1? Yes. Only very few ratings. And that's indeed true. So the movies who got the really, really high 5-star ratings actually didn't get that many ratings. So it was really, really easy to get this high average rating, right? So it doesn't necessarily mean it's the best movie in that database. Yes?
Can we use the order function and like order the series? That's what I did. Like you take the ratings and then you just put .order and then you put in the parameter to make it list it in descending order.
Oh yeah, so the question was, can you just order the list and then pick the 5 best? Yes. Yes, sure. As I said, there are typically at least 3 ways to solve a problem, and I'd say at least 8 ways to solve something in Pandas. So yes, totally fine to use an ordering. So, and about this ordering, so we counted things, we calculated the mean, and I showed you that with tab completion you can see what else all the functions are that you can call on a group by object, right? So you can group by user ID, and then you can hit .tab completion. You're going to see what you all can do with the group by data. But sometimes that's not enough. Sometimes you want to do something else. So what you can do then is you can pass a user-defined function. And for that in Python, we have these lambda functions. So you see this lambda keyword there. So you say lambda, and then you give it the parameter of the function. It's just like a normal function declaration that you know from C++, Java, Python, wherever, but you don't give it a name because you're only going to use it once. So what you do is you just call it lambda. F is your parameter. Then comes the colon, and then is what you do with f. So here I'm being very lazy and simple in this example. I'm actually using a function that is already inbuilt, which is I'm just rewriting here to get the mean, right? My lambda function here has a parameter f, and the output is f.mean. So that lambda function is just the mean we had before. There was a question here somewhere. Answered? So I'm actually going to go a bit shorter on the quizzes because we're not going to do much scraping if I give, with the time there. So you can get the average rating per user and then list all occupations and if they are male or female dominant. If you want, you can do this at home. The more important part here is this is actually an example where I can use a lambda function. So what I'm doing here is I'm defining in apply here, I give it a lambda function. And I say sum up how many of them are male and sum up how many of them are female and tell me if the male sum is larger than the female sum, right? The sum of females. So that is my lambda function here, and you can totally just put that in here and apply it, and it gives you true or false whether the occupation is male or female dominant. So just an example how you can pass in lambda functions. So that was my Pandas wrap up. That actually took a bit longer than I thought. But this was important because you all can create data frames now. You can actually use the group by function, which is going to be really handy in assignments and in everyday tasks that you want to tackle. And you know how to apply a user-defined function. So let's go to the scraping part, which was the more interesting part, right? So Python data scraping. We have the whole World Wide Web out there. Tons of information. And it's all buried in websites. And some of these websites are really ugly designed. And it's really hard to scrape the data from them. But some also are nice. But there are libraries that help you, right? With everything in Python, most of the time you don't need to reinvent the wheel. Somebody out there has done the work for you. You just need to find the right library to use for your task. So you might want to do data scraping to access information, to automate tasks. Like people have Amazon, right? And look up prices and things like that. You can keep up with sites. You can compile your own newsletters. You can also just have some fun, right? Like we're going to scrape happy hours, for example, and look where it's nice to go on a Friday evening. These are examples where people made use of APIs. This is a nice visualization where somebody looked how New York Times articles are referenced in tweets. And basically after publication, how they distributed over Twitter. And this is another project where somebody looked at Twitter sentiments. So you can give here, the word is Grand Canyon. And you can look what people twittered about it and whether those tweets were more excited and happy or whether they were more depressed and unhappy. So one thing in the beginning is when you scrape data, especially when you do real HTML web scraping, please be polite. You need to take care about copyrights and permissions because the problem is nobody can really enforce them onto you because you can scrape whatever you can read in browser. So it's up to you to actually look at the rules and please follow them. Give credit when you scrape data. Care about the media law. And also when you scrape, be nice to their servers. Especially if you scrape sites that maybe are not Wikipedia and have this gigantic IT infrastructure, you can create a lot of hits with your little laptop. So put a timer in there, like sleep and only make a request every second or something. There's also a file where people explicitly specify that they don't want you to look at their stuff. And that is called robots.txt. So this file is normally found at the root of a URL. So www.example.com robots.txt. You can also look at the Google one. Google actually has one. And what it typically looks like is this. So it's going to say user agent, and then somebody, and then what is allowed or disallowed. And here it's user agent star, which means everybody, right? And then it says disallow. So this robots.txt basically says, Google, you can do whatever you want here. Everybody else, please hands off. So of course, this robots.txt, again, can just be ignored. You can't enforce it on anybody. And sometimes it's even worse to use it, because if you say, everybody disallowed diary.com, like subdirectory diary, you're basically telling everybody out there that you have a subdirectory that might be interesting to read. Right? So you might want to, there are pros and cons to having a robots.txt. So scraping, as I said, is scraping about normal HTML websites, which means you need to know a bit about HTML. But the good news is it's actually only very, very little that you need to know about HTML itself. You basically need to know that these HTML tags have angle brackets and that they typically come in pairs. What does that mean? This is an HTML string. So here are these tags. This is where the HTML site starts. You see tag, angle brackets, and down here is the pairing tag that closes it. So you have the /HTML closing tag. You have the head part and the body part. And here you see it's the same scheme all over again. Title, title closed. H2, which stands for heading of level 2, H2 closed. That's the basic idea. And you can see if I parse this as HTML and output it, it says test hello world. And test is so large here because I tell it this is a heading, heading 2. So useful tags to know are the headings. P, just the tag P is for a paragraph. A line break is BR. And then the links with attributes. Because often when you scrape, you actually want to scrape all the links from a web page. So what you do then is you look for those A tags. And inside the opening A tag, you see this whole thing in the beginning here? This is the opening A tag, right? The whole thing. You see the bracket closes here. Then comes some text, and here it's closing. And you see it's not only the A tag in here, but it also has an attribute. And this attribute is the actual link. And then we all know the spiel. Like you're going to get an example in blue, right? People can click on it, and they're going to end up wherever that link points them to. So when you scrape, you most probably want that link. So what you want is the attribute href of the A tag. And I'm going to show you how to do that. First, I wanted to show you a very, very useful tool. And this is the reason you don't need to know much about HTML to do successful scraping. When I click on that link, this is the beautiful soup, is the library I use for scraping in this lecture. You see, this is a very, very simple web page, which actually makes it very nice to scrape. The more sophisticated it looks like, most probably the harder it is to know where you actually want to go. So what I can do now is I just hit F12. And I believe there's also Ctrl-Shift-I. And in Safari, it might be Command-I. It's called Inspect Element. And what I get is this nice tool. And you can see here, I can go over the web page, and it highlights part of it. And let's say, for example, I want to look at this. Here's a list, a numbered list. And if I click on it, here comes the tag I'm looking for, ordered list, OL. So if I want to scrape this list of the web page, all I need to do is inspect element, highlight that part I'm interested in, click, and it's going to tell me the element I need to look for. It's not telling me anymore. Ah, there, highlighted. Ordered list. Of course, if there's more than one ordered list in the document, I have to take care again. But this is why you don't need, this is nice because you don't need to open the whole source code of the web page, right, and understand everything and know where you are. You literally can click on the interesting part, and this part is going to tell you what to look for. Okay, let's go back. I don't know how. Here we go. So this is it should be in Safari Command Option I. Does that work?
Yeah.
Yes? Okay, cool. So in Safari, in Chrome, it should be just F12 or Ctrl-Shift-I. So that is a really, really useful tool to remember if you want to do some scraping in your final project, or also for the homework. That is the way to know what you need to look at in a web page. So as I said, there are many useful libraries. I am using the more basic ones here, URLlib and Beautiful Soup. There are more elaborate ones. You can go all the way up, I believe, to scraping Flash stuff. Like there are tutorials on the web. Catherine Jamul, which I also cite in the pages, from hers the example with the LA happy hours, she shows how to scrape Netflix. Like that interface where you can scroll the movies, right? So if you, for personal reasons, want to update all your ratings that you did on movies or whatever, you can actually even automate that part. There are libraries for nearly everything scraping out there. So what I do now is I take the link to this web page, Beautiful Soup, and this is literally just the string as you would cut and paste it into the address bar in your browser. Instead of doing that, I'm assigning it to a variable, and then I use URL lec02 and do this URL open of the string and read. And that gives me a whole string just with all the HTML from that site. I just read the whole web page into one variable. That can be useful already if you just want to check for different words, for example. I used that. Here I had a quiz, which I'm not going to do for time reasons now. For example, simple things like, is the word Alice mentioned on the Beautiful Soup homepage? You don't need to do anything more than just get this one big string, because all you can do is ask in Python, is Alice in source? Source has the whole HTML code from the whole web page. It also has all the weird HTML tags, but we don't care about, right? We're just interested whether the word Alice is somewhere in there, and we can check that with just one line of code. So Beautiful Soup is a library that makes your life easier when you do scraping. What you can do here, or what I do here, is I do Beautiful Soup of the source. Source was where all my HTML code went. So I'm now creating a Beautiful Soup object of this. And what this does is, this is now actually parsing the information. I said before you have this hierarchy, right? You have HTML open, HTML close, head open, head close, body open, body close. Before, we were oblivious to that. We just asked, is Alice somewhere in this whole mix-max of weird symbols and readable text? Now we're having a library that is actually parsing the HTML structure of the document. So now we can traverse the hierarchy. And we can do things like, as I said, we're often interested in links, right? You're going to be interested in links for the homework. So the idea is to find all A tags here. And this is now, this you can do because of Beautiful Soup. Before, with just this big, big, long string, if I asked for all A's in there, I would have literally gotten every A that is somewhere in this web page, plus all the HTML tags that have A's in them, right? But Beautiful Soup parsed the whole code and is now explicitly looking for the tag A. And that was how links were specified, right? Tag A, href, and that was the link where we wanted to go to. So this is how you actually get the link. You do find A, that gives you the A tag. And then from this tag, you use get and get this attribute href. So that is the actual link then in there. Does that make sense? We had this opening, A, right? Then href, HTTP something, and then it closed, and then there was some text here, and then came the A. Which direction is the slash? I think this way. A closing, right? So now I'm getting the A tag, and I'm asking for the attribute that gives me the link. This is how you scrape links. So I'm doing some data cleanup here now. I didn't want to teach you data cleanup. This is how you do A. This is how you do B. So it's kind of snuck in the examples. When you do this for the Beautiful Soup document and you get all the links, what you're going to see is you get some links that are external. Here, this is what we want most of the time. These are links to different web pages. You get some links that are internal. So these are just references to different places within that web page. And most of the time, those actually aren't that interesting. And we want to get rid of them. And then we actually also have 2 where it's none. And that can cause problems. So we need to filter those. And the first thing is we only filter for HTTP. Those are the external links, right? This is where it's linking to different web pages. So what I'm asking here is, for every link in the list, if the 4 symbols, the first 4 symbols of that string from that link is HTTP, I'm happy. And then I keep them. So I'm creating a new list, external links. And whenever the link started with HTTP, I'm appending it to that list. And this throws me an error. Why? Because we have these 2 elements in there that are none, and I cannot access the 4 first characters of a none object. Right? So we need to filter for that too. So this is what we do. This is the proof that there were nones in there. You can see the none is here, right? There's my none element. So this is what is causing this error message. So what we do now instead is we just modify our condition here and say if L is not none and the first 4 characters are HTTP. And this works because it's lazy evaluation, right? It's first evaluating the first part. And if that was already false, then it doesn't care about trying to evaluate the second part because it's the and in there. And false and something is always going to be false. So Python doesn't care about evaluating the second part if it already knows that L is none. That make sense? Can you also say if L? I'm actually not sure whether none is false by default. Is it? It might be. Never tried that. I normally try to be very explicit with my code, like that it reads. I'm most happy when my code reads like English. Which is why I actually also have this version for you, where everything is done. So this is for the more advanced Python enthusiasts. This is how to do it in a list comprehension. List comprehensions are something you're going to see in Python over and over and over again. So L for L in linked list. Here's a whole for loop within a list. I'm creating a list by going over a for loop inside of it. That is what is called a list comprehension. So L is the variable of the for loop, and it's going over the whole linked list. And I'm keeping it if L is not none, and instead of doing this elaborate, give me the first 4 characters, I do L starts with HTTP. And this is something very powerful. Python has a lot of functions to deal with strings, which makes data cleanup often very nice. Like lowercase, splits, joins, it's all in there. Like the string library in Python is really nice and good to use. So I already said that beautiful soup is basically parsing the tree, so you can address the different tags and the different contents now in a better manner. I'm going to skip over the quiz here, because I would like to show you 2 examples of scraping. So one is, we had this question, should we teach a lecture on Spark? Should we, shouldn't we? We have a lecture already on MapReduce, which kind of teaches the concept. So Spark is a big word, it's popular, how popular is it? So what I did was, I Googled, and I found this example from Jesse Steinberg-Woods, who scraped job offerings for data scientists about the skills that they were asking for. So that's the best way to find out, right? What do people actually expect from a data scientist? Should they know Spark? And the answer is yes. So the question is, what skills are in demand for data scientists? Our process, right? We start with an interesting question. Now let's gather some data. So Indeed.com is a web page that lists job advertisements. So we use this web page now and scrape it. So again, we just specify the URL. We read it using URL lec02. This now just gives me the HTML code from this web page. And now I parse it into a beautiful soup object. And you can see here, actually let me show you the web page. This is the web page I'm using. So data scientist, it's already in there because I did this before. And I actually think I left that blank. So this is what the web page looks like. You get up here how many jobs were found in total. You get 10 jobs per page. These are interesting points for us when we want to scrape. And in the middle here, first there are some paid for advertisements, and here are the actual results. So that's looking a bit more complicated than the beautiful soup web page. What you do is you hit F12, right? We do inspect element, and we end up looking at this. So this is one result, and you can see here the tag row result. So these are the actual tags we're going to look for, row result. That's all you need to know to do some scraping. So let me go back to this. So we have our fixed URL. We opened our HTML stuff. And now I'm going over all the different links in there and gather them, all the different external links. Like I would recommend going over this code when you have a spare minute. Like it should be pretty self-explanatory. So you go over every single link in there, in this URL. And I save them into one long list, which is called job links. So the first part is not to scrape the skills. The first part is to scrape the links to all the different job advertisements, right? The job postings. So this is what this part does. And then I did some canning here, because this takes some time. So you're going to find in the GitHub repository there are files that I'm reading in here so that you don't have to wait too long. So I only looked for MapReduce and Spark here. The original posting from Jesse also looked for R and Python and what else. So if you want, feel free to expand the example and scribe for different skills. And this is where the actual scraping now takes part. You can see it gets a bit more elaborate because we need to take exceptions here. So what we do now is we have this whole list of links, and I'm trying to follow each link, the first one, the second one, the third one. But sometimes I'm not getting access to that site. The reason being I read that web page not with the browser, but with URL lec02, right? I'm using this Python library. And at the moment, I'm using the default of that library, which means it's nice and actually telling that web page it's not a browser. That's being nice and saying, if you don't want to be scraped, ditch me, and they do sometimes. So this is why I catch these exceptions. Sometimes it's also just that they would like to use cookies and URL lec02 doesn't want them. So this is the whole try except block up there. And here's the actual getting the HTML text. And now what we do first is, this is interesting, this is a regular expression in Python. So what we do is we take the whole text and we filter it. First of all, we make everything lowercase, right? Because we know we're looking for MapReduce or Spark in those web pages. We don't actually know what the web pages look like. Those are now posted by different companies who are looking for data scientists. So we cannot rely on any structure. We cannot look for any tags. So what we do instead is we convert everything to lowercase, and we only keep readable text. We only keep the letters A to Z, and +3, because there's a visualization library that has the 3 in its name. That's the reason. So if you want to scrape for that skill too, you need to keep the letter 3. DS3, right? So now we're here looking. It's in a dictionary, the skill sets. So now I'm looking for all the skill sets that I'm looking for. Is it in my HTML text? And if yes, I'm increasing the counter. It's really very basic. It's not that hard. It's just taking the whole web page. You don't even need to know what it looks like. Getting rid of all the junk that you know cannot be MapReduce or Spark, right? And then looking whether that word is inside everything that is left over after the filtering. And turns out, so this is not all 22 job advertisements. I believe these are 500 that I scraped. And 31 were looking for Spark, and 16 for MapReduce. Which meant, of course, yes, we're going to have a Spark lecture later on. So I have a second example, which I'm not going to do, just that you know it's there. Catherine Jameau, I'm just going to want to highlight again, because she has really nice tutorials about scraping online and really good resources. She also gave talks at Python conferences, at PyCon. So those are online on YouTube. I highly recommend watching them. They're linked at the end of the slides. So she scraped the LA happy hours as her example. So the same idea, you go to the LA happy hour site, you look, it's an unordered list that you're looking for, you get all the different tags, you look whether your interests, burgers, sushi, sweet potatoes, fries, barbecue, and beer are mentioned in that particular happy hour, and if so, you keep them and put them in a list. That's the whole idea. Can see this here. So it's looking, paragraphs is what it's here now. And now this is in beautiful soup because they're all on the same hierarchy. You can find siblings in the parsing tree. If you don't know what I'm talking about, that's fine. If you know, that's also great. So, and then it's about all the happy hours that got found that have the interests in them. So this is now looking for the interests. And every time it's finding something, it's like, yay, I found some burgers, some sushi, a lot of beer. And then you can compile all the happy hours you're interested in into one email to you and send it. And you can even, there is an interface to send emails via Gmail in Python. So you can totally use the script now, modify it for Boston happy hours. And when you submitted your homework on Thursday night, you can go out on Friday night. OK, that was all I wanted to say about data scraping with the web. That was the more important part. I have 2 API examples. Then just to show you what it could look like. The problem with APIs is there are a ton of different APIs out there, and they're all going to look a bit different. So you need to read the documentation. You need to read what they allow you to do. And you need to see whether there are Python libraries who can make your life easier with that specific API. The Rotten Tomatoes API is very simple and nice because it's just JSON encoding what is happening. So the only thing all APIs have in common is that you will need a key. I don't think very many are free. Why? Because they want you to be nice. And they want also maybe to know what you do with their data. So you need to apply for a key for that API that you want to use. For Rotten Tomatoes, I think it's also asking you for your email address and things. And it's going to give you basically a password that you can use. That is also both ways. The more important part for them is they can identify you. So if you misbehave, if you're trying to spam their server or trying to do way more requests than they allow, they can identify you and write you an email and say, stop this, or we're going to cancel your account. That's the whole idea about API keys. So you always need to get those. I put the links here, how to get the keys for the results that I have, for the examples. And I show you here how to scrape Rotten Tomatoes. And it's really just, where's the, here. So for the Rotten Tomatoes, it's really just the URL. So all you do is you have your API key. And you actually, that function here does not exist. That is imported from my computer because I didn't want to show you the key, but I wanted to have a working example. So when you have your key, you need to put your key here, right? When you want to go over the slides on your own. And then you can see that URL here just has the key at its end here. This is not going to work anymore, but here it just says plus API key. So all you do is you take the whole URL and you put your API key in the end. That's all there is to it. And then it's just like before. You can just use URL lec02 to get the data and parse everything as you had before, with the exception, this is now nice. This is not giving you this HTML stuff. No worrying about tags, no beautiful soup. You get a beautiful dictionary because they're trying to make your life simple. So you don't need to parse yourself anymore. Instead, you get a dictionary out in JSON encoding. But what you do is you use the JSON library and just load data, and it's going to give you a data dictionary. So that now means this data here is already kind of sorted. So you can look at keys. Dictionary are key value pairs. So it's a name and a value. And you can see the dictionary you get has 3 keys: movies, link template, and links. Now I can look at the movie part just with the data frame. This is not a data frame, but I can look into that movie key, right? And then see what is in there. And you can see for each movie I have ratings, links, the title, the critics' consensus, all of that. So much nicer than having to really scrape this from a web page and out of the HTML code. They basically just say, here, big chunk of data that describes everything. In this case, about the top DVD rentals. And then you can do just fun stuff with that. I said build a list with critic scores and with audience scores. And you can put that into a Pandas data frame and, for example, do a plot here. And this is for each movie comparing the critic score and the user score. And I'm going to close here because it's 4 already. So I knew before that I had too much material. I hope we would go over the Rotten Tomatoes example in a bit more detail. But the main thing is you can only teach so much scraping. You really need to do it. This is also why this lecture was so heavy on coding. It's really, you need to sit down, you need to try it. Just take your favorite web page, right? Go like, oh, this is what I read every day. Maybe I can just get an email with the content, right? Just try it for yourself, because this is really what you need to do. So as I said, Catherine Jamul's tutorial is really good. Pandas, if you haven't worked with it before, extensive, great documentation. Especially there's one entry called 10 minutes to Pandas. So if you don't have much time, at least read that part of the web page. And Greg Reeder, from him was the idea with the movie lens data set. I simplified a lot of his code to give you an entry, and you can basically, from the basis you have now, you could follow his more advanced examples if you're more interested into more Python, Pandas, wizardry. Like, these are links to go to. If you have more questions, I'm here. I actually also have office hours right now until 5 if you want to come over. My office is in Northwest B164. Have fun.